Welcome back to What Should I Use? Today's episode is foundations, and we're going to talk specifically about the 4 control layers and how it plays with a foundation. That's why we're standing inside a walkout basement. And the reason we're going to talk so specific about the 4 control layers is because we get one shot. We get one opportunity before all of this gets backfilled, landscaped. We pour a patio, we pour a garage, it gets covered up, and it's going to be inaccessible. It's going to be difficult to get to. It's not like we can pull a few pieces of lap siding off and make a repair, or pull a window and make a repair. We literally would have to bring a backhoe or a track hoe, dig, put people down in a pit, move and excavate, and then put things back together. It would be a royal pain if we had to fix something here if we didn't get it right the first time. So the opportunity here is of greater risk if we mess it up. Let's do it right the first time. Let's talk about what right looks like. Let's do it now. What should I use? A Build Original series with me, Jake Bruton. So I want to start today's conversation by actually recommending a resource. And for once, it is not the code book. It is actually the Builder's Guide to Cold Climate. This is published by Joe Stiebrick and the Building Science Corp. And I understand that you might not be building in a cold climate, and that's okay. The book still generally applies. And the reason it applies is because it truly does address the 4 control layers in a very thorough manner. And it really is just about control. It's about the environmental separation and keeping the outside out and the inside in. Just because you're not in a cold climate doesn't mean that you're not trying to do that. It just means that maybe the stakes aren't as high as they are, say, as if you're building in Toronto, as if you're building in San Diego. And so it's still a very good resource even if you're in a mild climate, because we want to keep water out, we want to keep air from moving from one side to the other, and so forth. And so I think that that is an amazing place to start this conversation, and we'll recap that at the end as well. So that's where we start this whole conversation with the 4 control layers, is go and look at Joe's book, and it really is amazing, and they've just republished that book as well, not sponsored as well. So when we start the conversation about the 4 control layers, we always start the conversation with water and water management, because water is the #1 killer of buildings. If you look at what the Insurance Institute of the United States sees as the #1 cause for lawsuits when it comes to insurance claims, after grandma falling downstairs and things like hail that are out of our control, it is water intruding into buildings. And we don't have any control over grandma, and we don't have any control over things like hail, but we do have control on whether or not water gets into our building. And so we are trying to apply the same principles below grade that we will to the roof or our walls. And that would be down, out, drain, dry, keep water from being held in tension. So what does our system on the outside of our foundation look like? We have a myriad of things that get applied to our concrete, and they all work in conjunction, in concert, to make sure that we don't have water held in tension and we get that water away from the foundation as quickly as possible. So let's run through our layers. #1, we have a roll-on waterproofing or damp proofing. Depending on what product you're using, there's a nomenclature there and what the manufacturer claims it is or isn't doing. That roll-on coating is there to try to make the layer of the concrete, the outer face of that concrete, so that it does not absorb water or let water run through it. That claim, though, only works for us until the concrete cracks. We know from a basic physics level that concrete cracks. That is why we put rebar in it. And that crack, when we have a split, that membrane that we've rolled on or that we've applied no longer is continuous. When we have a break in a control layer, we no longer have continuity. It no longer can do its job. So that alone by itself is no longer enough. We assume that we're going to have cracking. So where we have cracking, we have to then apply something else. So Our first layer of protection is that roll-on or that fluid-applied membrane that goes on the outside. Next, for our systems, we always go with a dimple mat. We are fairly, let's see, how am I trying to say this? We are fairly inconsiderate when it comes to which brand to use. We really don't care. What I'm looking for here is something that provides adequate drainage. So I'm going to say at least 3/8 of an inch of drainage plane in this dimple mat, and that comes with a termination bar. So termination bar is a top cap that is made by the same manufacturer as our dimple mat. That way we can cap it and keep things from getting into the top. That dimple mat will run vertically from just below grade all the way down to the footing, and then turn horizontally across the footing and travel across the footing and out past the footing. That now is allowing anything that gets into the dimple mat on the inside between the dimple mat and the wall to then be a pressure relief. Think of this dimple mat as the exact same thing as a rain screen above grade. So when we look at rain screen for our siding, you know, we use a 3/8 furring strip or we use a 3D printed matrix as a pressure relief. It's just a space so that there isn't water held in tension. If we're not challenging that waterproofing that we rolled on the concrete by letting all the water drain, then we don't even have to worry about if we did a good job with it. So like, think backwards here. We're able to then go, okay, well, if it can't even get wet and the water runs off, then we're really not even that worried about how good of a job we did. It's very simple. Next, all of that water that could get in there has made its way all the way down to the footing. Our next part of our assembly is that drain tile. Drain tile is, again, required by code. That drain tile is a perforated pipe. That perforated pipe loops all the way around our foundation. It is a pressure relief, and it is going to pull that water that could find its way down there or find its way up away from the foundation. And when I say find its way up, that drain tile shouldn't be catching water from the surface. If we're getting surface water 6, 8, sometimes 10 feet down from the surface, we have other problems with our higher up system. That should be water table water that could actually be rising that we're unaware of. That should be catching groundwater, not surface water. And we'll talk about surface water here in a second. That drain tile, also for us, we perforate the footing, and we actually do a drain tile on the inside because we have gravel underneath our entire footing, and that footing, or underneath our entire slab, and then that slab can communicate with the outside and the inside of our footing, and then we have the ability to pressure relief the space underneath me and the space outside. That drain tile can then go to daylight. And by daylight, I mean naturally evacuate that water, naturally be a pressure relief. The code actually requires to daylight or mechanically pumping away. The challenge with mechanically pumping away is that takes power. Well, when do we normally lose power? When there's a storm. When do we normally have, what comes with a storm is water. So like, if we have water, we have a storm, we have power outage, that's when we need that pump the most. So that can be the issue with relying on a mechanical pump. We try to make it as fail-proof as we can. We have backups, things like that, but sometimes there is still a challenge in that situation. When it comes to drain tile, our preference is to have our drain tile be below the connection point between the footing and the wall as well. And the reason for that is because the weak point in the assembly that I've discussed so far is the cold joint between the pour of the footing and the casting of the wall, because that is a cold joint. It is not monolithic. It is a breaking point. And so we want any of that rising water from below to be captured by that drain tile and evacuated before it gets to that potential cold joint, before it gets to that weak point. So we do perforate our drain tile all the way around because we want any water that comes from above and any water that comes from below to be captured. How do we then protect that drain tile from silting in as well? That drain tile for us is a hard pipe. It is a Schedule 35 pipe that's perforated. It is totally encapsulated in clean rock, and it is then wrapped in a filter fabric. We call it a burrito. We use a 6-foot filter fabric that is a landscaping fabric. it is wrapped in during install so that we are completely encapsulated, and it is wrapped actually past the foundation, and once we get past the foundation it goes to solid pipe so that we can't have silting in once we get out past our exit point. The other important aspect to understand is that this is not for our downspouts. We're not communicating with the downspouts, so even though we are burying downspouts, they are not part of this system. They are actually even buried at a different elevation. And we have cleanouts for this system as well, because while we're trying our best to keep this system from silting in, it is still possible for things to happen, and we want the ability to clean this out. So while we could go to the ends of our pipe where we have daylight and track back, we also put about every 75 feet, depending on twists and turns, just below the surface we'll bury a downspout, and then we'll mark it on the as-built plans that we leave with the clients. If we ever think we're having an issue, we can come back, move the landscaping away, and dig down and find our cleanout, and then have access to this. Now, we have all of our systems in place. We now have to backfill. We have that burrito. We still cover with more gravel. Every bit of gravel that we can put in the hole, that's just one more place to relieve pressure. The more soil you put in, the more pressure that we put on the foundation, the more likely we are to hold more moisture in tension up against the foundation and the foundation walls. So we want to backfill as much as we can with gravel, but we also know that we do have to get rid of that dirt on site. We do have to backfill with some of what's on site already. So we are working gravel and dirt back in as we backfill all the way up to grade level. Once we get to grade, we are going to cap with clay-rich soil here in Missouri. That is not an issue. We have clay-rich soil and it's easy to come by, and we are going to work to have a grade sloping away from the building so that our surface water is easily moved away from the foundation. I will tell you that the overwhelming majority, if not all, foundation water issues that I've ever dealt with have been solved with foundation grade and gutters, not digging up the foundation. So while I made our initial sales pitch about this is going to be horrible to fix if we ever have a problem, every single time I've been called in to fix someone else's foundation issue, we've dealt with it by fixing grade and by burying downspouts. And that's proof that these are the most important steps once we get to backfill, that we have to manage the surface moisture. That surface moisture, at least in my market, is substantially more than groundwater. In your market, that might not be the case, but managing that grade and what comes off the roof, because all of that is our building, in this case we have like a 2,000 square foot footprint, is going to come down in like 4 pipes that are all feeding to right next to the foundation, and if we don't manage those, that water is going to wind up down here challenging this system that we've put in place. So now we have all that water pushed away from the building. We have a system where we're taking care of that number 1 control layer, that water. Now we can move on to our second control layer, which in this case, air, is kind of the most simple and easiest one to deal with. Concrete is a pretty darn good air barrier. In fact, it's an excellent air barrier. There are people that will say that it isn't, but as Steve Basic says, put your lips up against it and try to blow through it, and you will see that it is a very good air control layer. And in fact, when you put the slab and you backfill, you also have the soil as an air control layer. So we really have not much to worry about on the air control layer front here. Continuity wise, we have all of our framing details so we can connect to the walls, we can connect to the next floor. It really is quite simple from that aspect from our air control layer. So our continuity in this aspect, this is one that we kind of get a pass, where the rest of the building, we focus very hard on air control and on mitigating our risk and worrying about how things are flowing through the assembly. Here, that 8-10 inch concrete wall, that 6-inch concrete slab, we're fine. Like, it really isn't a problem for us, and we get to move straight on to our thermal control layer, and we kind of luck out in this instance. So when we shift onto control layer number 3 and we're looking at continuity of control layers, The code actually talks to us about continuous insulation below grade, and we have all these options, and we actually think of this as the perfect opportunity to apply continuous insulation. We don't like putting things on the outside of the foundation. I understand the argument of if we put it on the outside of the wall, it warms the concrete. We have too many things in the way of termites and insects, and I don't think that we've discovered a great way to put things on the outside of the wall and then protect it. So we just keep everything inside when we're below grade. I just think it's easier for our systems, for our methods, to just have it be inside the building and it be easier to protect. And there is a push-pull there. I realize we take a little bit of an energy ding that now we have that cold concrete that's going to connect to framing. However, it's protected and it will be safe for the lifetime of it. It'll be inside of our building rather than buried on the outside. So what do we have here? We have a continuous cooler of insulation, basically. You can see what we're looking at here. We have a sheet foam insulation. In this case, we'll actually talk about what we have. We have a Halo GPS insulation. It is a graphite polystyrene. So think coffee cup, but infused with graphite. It has less thermal drift over time, meaning it off-gasses less chemicals into the atmosphere, and therefore it loses less R value. Most foam insulations off-gas and lose some of their R value over time. We happen to use this one for that reason. It's also made and manufactured closer to us than some others, so that's a benefit for us. What we have is we have the product on our walls. It gets fastened directly to the concrete, and then we have the product dive below the foundation, and then underneath our concrete is another product from the same manufacturer. It also is a thermal break between our slab and our perimeter stem wall on the back of the house, and our slab and our walls on that you can see next to me. Meaning all of what I'm standing on, concrete slab wise, is thermally broken from the walls, both our stem wall on the walkout side and our foundation walls on the perimeter. So while this is concrete that I'm standing on, and that is concrete, they don't touch. So our thermal control layer has continuity. That continuous conversation happens another time here. And it is very simple to have that conversation when you're working with a simple aspect of a sheet foam insulation where you can just put a piece in and then pour concrete up against it, and then you can cut and slice things. If this were a spray insulation, it would be much more difficult to deal with things like that. Or if this were a bat or something like that, the conversation would be a lot more difficult from a order of operations standpoint. So material choice here makes our continuity of control layer much simpler. So that right product, that right choice makes all of that control layer very simple to install and makes the continuity of the thermal control layer easy to execute. Our fourth and final control layer in this instance is actually the one in our market that we generally don't really worry about that much. If we do a good job with the other control layers, we're not leaking air, we're not leaking water, and we have a good thermal control layer and a well-functioning HVAC system, we're not too terribly worried about vapor, except for when we're in a basement. We don't want vapor drive from the soil, and in this instance, our vapor barrier is also doing double duty because we have a radon management system here. So what we have is we have a 15 mil poly that is below our thermal control layer here. It goes the entire breadth of the assembly here. It goes over, it turns up the wall a ways, and then it tapes to the wall before any of the concrete slab goes into place. All of its seams are taped underneath of us, and so it is continuous, it's easy to install, and if you were paying close attention, I said 15 mil, where if you go to the hardware store and you were to look at polyplastic, you might go, oh, well, I see like 0.04 mil, I see 4 mil, I see 6 mil, and you're seeing painter's plastic and then traditional poly that's easy to come by. Why 15 mil? Well, even though we're only after vapor and we're not after air, vapor is a uniform load. It won't puncture through everywhere with great force. You know, if we poke one hole over here, not everything's going to run through that one hole as air would. That 6 mil poly, if we put it down like we used to, the concrete guys are going to show up and they're going to walk on it and spread bar everywhere. Or the guys spreading foam are going to walk on it and they're going to be on top of rock and they're going to poke a bunch of holes in it by walking on it. And vapor is a uniform load. It will filter through all those little holes. It might not cause a problem, but by going to a 15 mil poly, whenever we get in here and we start working on top of it, we don't have to worry about walking on it because we're not going to poke holes in it. It's just going to be a little bit more durable. If you notice behind me, there's a little bit of water on the site today. There's mud. It's not a clean area. It's a job site. Things happen. By picking something that's just a little bit more durable, it lasts better while we're here working. Once it's covered up with concrete or with foam, it's probably not ever going to get seen again. It's probably not ever going to have an opportunity to get damaged. However, in the working life of it being exposed, we don't have to worry about it and its performance by choosing to spend a little bit more money, a little bit more coin to buy something that is just a little bit more durable while it is exposed. So we have that vapor control layer that is also our radon control layer. Those are our 4 control layers. What have we done here? We have managed water. We have gotten it away from the foundation as quickly as possible. We have managed it to keep it from getting to the foundation with our grade, with our gutters. We have managed for air by doing a really good job with just pouring good concrete. We have managed our thermal control layer by doing everything in a continuous fashion, using the right materials, placing them in the right locations so that everything is thermally broken. We've insulated the entire bottom of the slab. Even though it's not required by code in some places, this thing is completely thermally broken so that it will be the temperature of the building. And we have a thermal control layer. We've chosen materials for our vapor control layer, the same as all of the other control layers, to be a premium product because we get that one opportunity, that one option, that one shot that we're going to cover it, we're going to bury it, it's going to be behind concrete or under soil, and it will be a royal pain if we ever have to deal with it again. So these are the things that we're going to take the opportunity to do it what we think is the absolute best practice that we have the ability to do for our budgets, and we're going to include this from the beginning in our budget. And I think that that's the key to success here. Is there are places for value engineering, and this is a place that we don't have a value engineering conversation. There are habits in the bid process where you go, oh man, they don't have that much money to spend on a house. Where can I save money before I take them the initial bid? And we have this habit as builders to go, oh man, we could spend a little less on windows, or I bet I can find a flooring for less. Where I'm standing right now is a place that you just don't do that. And I think that that's one of the big takeaways from today. Like, if you understand the control layers already, that's great. If you understand all of this already, that's great. But if you can convince yourself to not give a good, better, best for the location that we are today, if you can convince yourself to say, I don't ever want to have to warranty anything down here, and I don't ever want to have an issue with anything down here, and my clients will thank me if we don't ever have to have a problem with anything down here, and I just have to figure out a way to keep this money in the budget, you will have greater success, you will have less headaches, and you will have happier clients. Trust me, I promise. So, think about the 4 control layers, think about the long-term aspect of what we're doing here, and think about the fact that you never want to see these things ever again, because if you do, it's a big headache. Till next time, thank you for watching What Should I Use? Have a good day.